All right, this is the Algebra 1, Unit 4, Lesson 3 video over arithmetic sequences. Arithmetic sequences are sequences where you've got a list of numbers and they are going up or down some consistent amount. So this would be an arithmetic sequence here. So 5, 9, 13, 17, and they might continue on for any number of terms. So each one of these items is called a term. So 5 is term 1. 9 is term 2. 13 is term 3, and so on. And the way we write that mathematically is this is A1, A2, A3, A4, and then it continues on, and you can have any number of terms. So whatever term we're looking at is always written as A with some number. And so generally speaking, we call that AN, or the nth term. So we have first term, second term, third term, fourth term, nth term. That could be any number that we choose. We can make a term out of it. So what you're going to be doing is two main things. First thing you're going to be doing is identifying the different parts of this type of sequence, and you're going to be looking at the formulas for these sequences. So the formulas for these sequences take a general form that you see here. AN, or the nth term of a sequence, is equal to the first term plus the term minus 1 times D. So just as an example, the formula for the sequence you see down here is the following. AN equals 4n plus 1. You might think, well, how do you know what that is? Well, first of all, I made it up. But we can see that when I take 1 and plug 1 into this formula, because I'm going to find the first term, and I do A1, and I do A1 equals 4 times 1 plus 1. I get 4 plus 1, which equals 5, which is the first term of the sequence. And if I continue doing that, 4 times 2 plus 1 is 8 plus 1, that's 9. A3, 4 times 3 plus 1 is 12 plus 1, 13. And then just so I can finish it out, the fourth term is 4 times 4 plus 1, which is 16 plus 1 equals 17. And you can see that by plugging in each term number into the sequence, I can use this formula to find the individual terms of that sequence. And so the values here in this formula are written here in blue. AN is the first term, or is the nth term, or term n of the sequence. A1 is the first term. N is the term number that you're looking for. And D is what we call the common difference. So the common difference can be easily found. So let me write another sequence down. This is one of the things you're going to have to do. Let's say my sequence is 2, 5, 8, 11, 14, and so on. So what is the common difference of this? So the common difference is going to be how much it's changing from one term to the next. So I see to go from 2 to 5, I add 3. 5 to 8, add 3. Add 3, add 3. So this should connect to the ideas of linear functions that we've been working with in this unit so far. So in this case, D would be 3 because the common difference, or the amount it's changing from each term to the next, is 3. What if I had the following? 14, 9, 4, -1, and so on. Well, let's look at what happens. Well, to go from this 4 to this 9, I subtract 5. Then I subtract 5 again. Then I subtract 5 again. And so the common difference would be negative 5. And so that's generally speaking how you're going to go about finding the common difference of your terms. Let me get in here and go over here. That's one main component of this lesson. So starting with number 4, determine if the list of numbers is an arithmetic sequence by choosing yes or no. If yes, then choose the option with the correct D, common difference. So the way you know if it is or isn't is if every change from one number to the next is the same. Like I showed you, each of these had a change of the same amount. 3, 3, 3, 3, 3, negative 5, negative 5, negative 5. So you need to check that every number is the same distance from the previous number, and then choose the answer that has that number. If the change is not consistent, then you need to choose no. So that's what you do for number 4, number 5, number 6. Confirm that the change is consistent, and then choose the answer that has the correct common difference. All right. Starting with number 7, they are going to walk us through, or they're going to have us find an nth term of a sequence or series. So let me jump down here. Let's go ahead and use one of the examples from up here. I'll use the example 2, 5, 8, 11, 14. Let me write this down. 2, 5, 8, 11, 14, dot, dot, dot. And let's say they said, find the 12th term. Find the 12th term. So that tells me a few things. And the first thing I need to do is I need to identify all of the values from this formula. Again, this is the formula for the formula for any number in a sequence. A(n) equals A1 plus 1, sorry, n minus 1, I got that backwards, n minus 1 times d. Mixing up a lot of my writing today. Okay, so we need to identify these values. We need to identify an, a1, n, and d. And actually, this is what we are finding. We're looking for an. We're looking for the 12th term. So I'm going to go and write that down. We know we are looking for A12. We want to find the 12th term. So what is that? Okay, so, well, in order to find that, we already see that my n value is 12. That's because we're trying to find the 12th term. My first term is 2. It's A1 right there. So this is n. And the d is what we determined earlier. We know that each number to the next is plus 3. So that means that d is positive 3. So then all I have to do is take these numbers and plug them into the formula here. So here we go. So A1 is 2, n is 12 minus 1 times d, which is 3. So now it's just a matter of working this out. So A12, use a different color real quick. A12 equals 2 plus 12 minus 1 is 11 times 3. 2 plus 11 times 3 is 33. So then A12 equals 35 right there. So that is our answer for the formula, or sorry, rather the 12th term of that sequence. Let's do at least one more example here. Let's say I'm given a series and it starts here, let's say 42, 36, 30, 24, and so on. And they want us to find the 10th term. So first things first, we have to identify all of our values from our formula. An equals A1 plus n minus 1 times d. So we have an, which in our case is A10, sorry. We are looking for the 10th term. We don't actually need to write that down. We know we're looking for the 10th term. We know that, so that tells us that n is 10. We know that the first term is 42. And we know the common difference is, and if we go up here, we can see each number is going down by 6 from one to the next. So then D is negative 6. So then I come over here and I say A10 equals 42 for A1 plus 10 minus 1 times D, which is negative 6. We're not going to let those negatives kind of throw us off. Keep moving. 42 plus 9 times negative 6. 42 plus 9 times negative 6 is going to be negative 54. So then A10 equals, if I went into my calculator and added this up, 42 plus negative 54, I get negative 12, and that is the final answer. The 10th term of the sequence is negative 12. I continue to subtract 6. That's what you're doing in number 7, number 8, number 9, number 10, number 11. All of those continue. Term number, A1 and D, plug them in and find the correct value for that. Number 13, what are the first 3 terms? This means that you're going to take and you're going to plug in for n. You're going to take n equals 1, n equals 2, and n equals 3. And you're going to plug those into the n in that formula and find out what each of those terms would be if you put an n right here in the formula. Next one, says what is the common difference for the sequence negative 2n plus 7? Just so it's clear, in any given formula like this, any arithmetic sequence formula, the n always has the d with it. So the d in this case would be negative 2. It's always the coefficient of n. Very important idea. So the coefficient of n is always that. Next one, choose the correct expression for the nth term given the sequence. You need to take n equals 1 and see, do you get an answer of 5? Then take n equals 2. Do you get an answer of 9? In other words, do the values that you get when you plug in 1, 2, 3, 4, 5 match up with the answers you see here? So you find which of these formulas gives you the correct answers when you plug in 1, 2, 3, 4, and 5 and get the answers for those terms. All right, so that's it for lesson 4 of Algebra 1, Unit 4. Lesson 3 of Algebra 1, Unit 4.